Extraneous solutions. If you remember from yesterday, we usually set up two equations when we had absolute values. So for example, if I had something like the following, the absolute value of 2x plus 1, oh, I always do that. The absolute value of 2x plus 1 equals 4. How would I go about solving that? What's the first step? Yes, in the gray. Yes, it's perfect. 2x plus 1 equals 4. 2x plus 1 equals negative 4. Just like that. And then you solve, right? So you would subtract 1 and subtract 1. Subtract 1 and subtract 1. 2x equals 3. And 2x equals negative 5. Divide by 2. X equals 3 halves. Divide by 2. X equals negative 5 halves. And then you have to check to see if they both work in the original. So I'm going to plug this back in. 3 halves times 2 is just 3 because the 2 on the top and the 2 on the bottom eliminate. So it's just 3. 3 plus 1 is 4. And the absolute value of 4 is 4, so this works. And then for the next one, you plug it in as well. 2 times negative 5 halves is negative 5, plus 1 is negative 4. And the absolute value of negative 4 is also 4, so that works as well. Now, you will not always run into situations where both of them work. And this is a word you need to know for the quiz tomorrow. When you check and your answer does not work, it's called an extraneous solution. I think of the word strange when I think of extraneous. It's when you have two answers, you plug one in, and one of them just doesn't make sense. It doesn't equal 4 in this case. It would be 4 equals negative 4, or 4 equals 3, or something like that. Then what you have is called an extraneous solution. It's an apparent solution that has to be rejected. It doesn't work. That's why it's always important with absolute value equations that you always check your answer. Does that make sense? Do you have questions about that? Yes, no? We're going to look at one more example, and then we'll be done with 1.4, and then we're going to look at your quiz. So for this one, you're going to do the exact same thing. It's set equal to a positive, so you're going to split it up into 2. 2x plus 12 equals 4x. And then 2x plus 12 equals negative 4x. And that's what they did here. Here and here. Now, they solved it just like you would any equation. And they got 6 and negative 2. But something strange happens when you plug in these answers. When you plug in 6, it works. 2 times 6 plus 12, the absolute value equals 4 times 6. So you have to plug in 6 everywhere you see an x. So that's 12 plus 12, that's 24, equals 4 times 6, which is 24 as well. So that works. But then, when you plug in negative 2, you get 2 times negative 2 plus 12 equals 4 times negative 2. You get negative 4 plus 12 equals negative 8. Can I ever have an absolute value equal a negative like that? No. So that doesn't work. That means that negative 2 is extraneous. Does that make sense? And remember from yesterday, there are instances where you may have something like this. Maybe it's the absolute value of x plus 1 minus 3 equals negative 1. If you look at that right away, you think, oh, it doesn't have a solution because it has a negative. But what do I have to do first?
Add 3 to the negative 1?
Yeah, if I add 3 to the negative 1, it becomes a positive now. And on tomorrow's quiz, I might give you a question like this and say, what's the first step? And you'd say, add 3. And when you add 3, you get this, and I can solve that. Does this all make sense? Kind of, sort of? Do you have questions on it? No. Okay. I have your quizzes graded on Aries. If you want to see your individual score and what you missed, you can talk to me about that. Okay, so, yes. Yeah, I would pass. The answer to number 1. What property of equality can be used to solve the following equation? X minus 4 equals 5. What'd you say? What do I do to solve for x? Yes. Yeah, you would add 4, so that's the addition property of equality. Number 2 says 8 times the difference of a number and 3 is 40. Which one is that? Someone else. 8 times the difference of a number and 3 is 40. Yes. Yes, that's correct. 8 times the difference of a number and 3 is equal to 40. Let's look at the next one. Solve the following, show all work. So what's one way to do this, the first one? Someone else. Someone else.
For number 3?
For number 3, yeah.
What's in the parentheses first?
Distribute, right. Because I can't just add a 2x and a 5. So I'm going to have to distribute the 2. 2 times 2x is 4x times 5 is 10 equals 10. And then I subtract a 10 and I subtract a 10. 4x equals 0. Then I divide by 4 and I divide by 4. What's 0 over any number? 0. Good. The next one, p over 5 equals 3. How do I get p by itself here? Yes. Yeah, multiply both sides by 5. Okay? Because this 5 and this 5 cancel out, because one's on top and one's on the bottom. So you get p equals 15. So you have to multiply both sides by 5. Question number 5 says, if an equation is determined to be an identity, how many solutions does it have? Yes. Infinitely many. What's an example of an identity? Yeah.
4x equals 4.
Not quite. Yes.
4x plus 10 is equal to 4x plus 10?
Yes. 4x plus 10 is equal to 4x plus 10. If the equations are the same, they're considered to be an identity. That means you're going to have infinitely many solutions. Okay. Number 6. How many solutions does the following equation have? So I'm going to solve this one. How do I go about solving it? Yes.
Minus 4 on each side.
Yep, you can subtract 4 on each side. I have 2x equals 2x minus 5. And then what?
You add the 2x and then 2x, and then subtract.
Yeah, subtract them. What's that mean?
Yeah,
No solution. Right. Okay, and then you had another one. Solve the following, show all work. So what's the first thing that I have to do?
Negative 6, 9 plus 60, and then 4 plus negative 6.
Yes. So when I do that, I get negative 66. So I'm going to combine my like terms first. I'd get 7n plus 4. And then I'd have to subtract the 4. I'd get negative 70 equals 7n. Divide by 7, divide by 7, n equals negative 10. Okay, question 8. Sally is solving the following problem. 2 plus 2x equals 3x plus 6. First she adds 2 and 2x, claiming that they are like terms. Can she do this? Are they like terms? No. So she cannot because they're not like terms. What are examples of like terms? 2 and 2. What are another pair of like terms? Yes. 2x and 2x, or 2x and 3x, or 1/4 x. All these have x's, right? So these are all like terms. You can just add them all together. Does this make sense now? Last two. During winter break, the temperature fell from 55 degrees Fahrenheit at 10 a.m. to negative 24 degrees Fahrenheit at 6 p.m. Write an equation to model the situation and determine how many degrees the temperature fell during the time interval. So you started out at 55 degrees and you fell a certain amount. That means subtraction, yes? A certain amount, you don't know how much, and you ended up with negative 24. Does that make sense? So right away I already know that this must be my solution, and then I solve just to make sure. I get negative x equals negative 79. X equals 79, so the temperature fell 79 degrees. Now, when I say write an equation to model the situation, that is B. C is not the equation that models the situation. Are we all right? Okay. Okay. So that doesn't work. This should say every math statement, but I figured you knew what I was talking about. Does every math statement have a solution? Does every math statement have a solution?
No.
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 There, you may have no solution, right? So this is false. So that was your quiz. Do you understand it all now?